Okay, here we go. This is 1.3 measuring angles for geometry. This is the second video. I did my last video on my DocCam, so we should have all this stuff filled in. We're going to be starting here in this section about classifying angles. This should be review for us, hopefully. We've got an acute angle. Let's draw a picture here. Acute angle is going to be less than 90 degrees. All right. A right angle, let's make sure it's a good right angle. A right angle is going to be 90 degrees, and it's going to be denoted by this little box in the corner. All right. An obtuse angle is going to be more than 90 degrees, and a straight angle is just a straight line. And we call it a straight line because a straight line is 180 degrees. All right. Okay, moving on. Okay, so we're going to be looking at this diagram here and answering some questions. So what's important here is to look at the little markings here on this figure. And so there's like these single arcs, there's double arcs, and triple arcs. Okay, so we just need to recognize that the singles go with the others, with the singles, and the doubles go with the doubles, and the triples with the triples. Okay, same thing as last week with like a single line went with a single line segment like that. Okay, all right, so let's give a shot and hopefully these start making sense. So angle CBJ, so let's see, CBJ, and so they're talking about this angle here because they're, B is in the middle, B is the vertex here. So CBJ is congruent, it's asking, with what other angle? So we have to look. This one has two arcs, so we need to look, and this one has two arcs over here. So how do we label this? We can label this a few ways, but what's important is that H is in the middle. Okay, so I'm going to label this GHF. Angle GHF. Okay. Erase those. Angle FJH. FJH. Okay, it looks like this little angle in here, FJH, is congruent with what other angle? It looks like this one has three markings. We need to look over here. There's three markings. So angle FJH is congruent with angle BJA. Okay, angle BJA. You could also say AJB, but what's important is that J is in the middle because that's the vertex. Okay? All right. So that's one way you'll see these types of problems. You'll also see actually asking about measurements or angle measures. So if the measure of angle EFD is 75, so let's find that first. So EFD, so that's right here. If this is 75 degrees, then what is the measure of JAB? Well, JAB is right here, okay? So they're referring to this little angle here. Well, they both have the single markings denoting that they are congruent. So the measure of JAB is 75 degrees. Okay, so these should be pretty easy for us. The measure of GHF, as long as we're looking at the right thing, GHF, that's this one again, was 130. Well, then the measure of JBC, so there we go, we're talking about this angle. Got the double arcs, so this one is 130 degrees. Okay, all right, moving on. Whoops, there we go. Angle bisector. An angle bisector is a segment, ray, or line that divides an angle into two congruent angles. Okay, so let's draw a picture of this. It says ray, KE, because of the marking on top, right? We got no arrow on this side, but an arrow on one side. So that is ray KE is the angle bisector of angle K. All right, so let's make K a nice big angle K. So that means this is the end point here, and ray KE is going to be splitting this right in half. I'll put point E there as well. So what this is saying is that if this ray is the angle bisector, okay, bisect means it's cutting in half, right? If you ever bisected a frog in science class, it means you're cutting it in half, right? So if that's the case, we're cutting this angle into two equal rays or angles, okay? So these angles are congruent, or that we don't know what the measure is necessarily, but we do know that they are the same. Okay? All right, moving on. Here's the tough stuff. Really, we've been doing this since last week. It's not too bad, as long as we label everything out. We've got ray AT, that's right here, is the angle bisector of angle MAH, so the big guy right there. All right, I'm going to give you some information here. Measure of angle MAT, we're going to say that that is 60 degrees. And the measure of angle TAH is 4x plus 20. So I always like to label these, at least put them in there. So this is 60 degrees, and over here is 4x plus 20. And we know that if this is the bisector, right, if this ray is bisecting it, that means these angles are congruent. Okay, if they're congruent, they're equal to each other, so we can set them equal to each other and solve. All right, that's how we can solve for x. And this should be reviewed for us at this point. Just going to solve for x with our boom, boom. We're going to get x is equal to 10. Okay, moving on. This one's kind of a two-step problem. First thing we want to do is label some stuff. I'm going to give you another little piece of information here, the measure of angle VOE. Let's write down this is 3x plus 14. Okay, so given is the measure of LOV is congruent to the measure of LOE. All right, so let's see. The measure of LOV is 7x minus 14. So like I said, I always like to write this in here. This is 7x minus 14. And over here, VOE is 3x plus 14. Again, these are congruent, so we can set them up equal to each other. Okay, so we're going to find x. So we got 7x minus 14 is equal to 3x plus 14. And we're going to just solve this equation. We got variables on both sides, so it's probably best to get your variables on one side. So I'm going to try to eliminate the smaller of the two coefficients. We've got 7 and 3. Coefficient is the number in front of the variable, so I want to get rid of the smaller one. That way I'm dealing with a positive coefficient later. So 7 minus 3, or 7x minus 3x is 4x. Drop down this negative 14, the equal sign, and the 14 on the other side. And now I want to isolate x, so I want to add 14 on, add 14 on both sides. And I'm left with 4x is equal to 28. And divide by 4, divide by 4. Again, x is equal to 7. Okay, but we're not quite done there. It says we also need to find the measure of LOV. Well, LOV, it says up here, was 7x minus 14. But we know what x is, so we can just substitute that out. 7 times x, which is 7, minus 14. 7 times 7 is 49, minus 14 is 35. And this is a measure, so this is talking about degrees. So we got x is equal to 7, and the measure of LOV is 35. All right, that's all I got for you today. And that's pretty much it for notes for the week. So you guys can work on these practice problems 1 through 18. Just keep in mind 17 and 18 have two problems in each of them. All right, later.